Hi and welcome to my video tutorial on empirical formulae and reacting masses. Now the empirical formulae tells us the simplest whole number ratio of each atom of each element in a compound, and reacting masses tells us how much of something can be formed or how much of something will be needed in a chemical reaction. I'm going to go through two easy ways of making sure that you can answer these questions fully and confidently without any problems. Now for empirical formulae, you can remember the order in which to write these down by learning this little rhyme or by listening to my catchy little jingle. Percentage of mass, mass to mole, divide by the smallest and multiply till whole. Percentage of mass, mass to mole, divide by the smallest and multiply till whole. As I always say, learn the rhyme, get it right each time. Okay, so here's a typical exam question. So let's see what we've got. A sample of copper nitride contains 3.81 grams of copper and 0.28 grams of nitrogen. So it's copper nitride, so I like to write it out in order of the formula. So first of all, I write the symbols for the copper and the nitrogen. And the next thing we're going to do is, as the rhyme says, write down the percentage or mass. Well, in this question, we've been given masses. So for copper, it's 3.81, and for nitrogen, 0.28. Right, our next step is to work out the number of moles. And don't forget, from our little triangle, mass, Mr. Mole, to work out the number of moles, it's mass over mR. Well, in this case, we haven't been given the mR, we've been given the AR. So mass divided by AR, in this case, will give us the number of moles. So from the question, we've been given this bit of information here. Or if it's not in the question in your exam, it will be on your periodic tables. So for copper, we need to divide the mass by 63.5. And for nitrogen, we need to divide 0.28 by 14. And if you put that into your calculators, you will get 0.06 for copper and 0.02 for nitrogen. Right, the next part is to then divide by the smallest number. Well, we can see the smallest number from this calculation is 0.02. So we're going to divide both sides by 0.02. Now, if you divide any number by itself, obviously that's going to come out as 1, and 0.06 divided by 0.02 comes out as 3. Now the last part of the rhyme, multiply till whole, doesn't actually apply in this case because we've actually got two whole numbers. So the final part comes from writing down the final empirical formulae as asked in the question. So this will come out as copper, Cu, and we can see our simplest whole number ratio is 3, nitrogen, and it will be 1, but we never write a 1 next to that number because we assume if the element is there, we don't need to put that number. Now let's just say in the exam question, when you got down to this stage here, by divided by the smallest, if you come out with two numbers like 1.5 and 2, obviously that last part, the multiply till whole, would have to be done because the empirical formula is the whole number ratio. So you just multiply that to get into a whole number by 2, so that would obviously come out as 3 and that would come out as 4. So just be aware of that last little step. And in the exam, they usually give it to you as 0.5s, so it's always times by 2. Okay, so let's move on to the next part, the reacting masses question. Now I've split this into two halves. I've got a cheats method and I've also got a proper mole method as well. Now a lot of students prefer to use the cheats method because it is actually quite quick and straightforward. So I always start out by writing down the equation as given here. So we've got 2 ions plus 3 chlorines goes to produce 2 iron chlorides. Okay, so let's see what it says in the question. So what we want to know is the maximum mass of iron 3 chloride. So first of all, I underline the iron chloride over here, and we want to know the maximum mass of that. So I'm going to put a little question mark above it. The next part says that that can be produced from 11.2 grams of iron. So underline the iron, and above it I'm going to write 11.2. Okay, so the next step is to then, underneath these lines that you've drawn here, because these are the only two parts that you are interested in, we're going to write down the MRs for each of those compounds or elements. And whenever you're using the cheats method, you must always include the number of moles as well in front. So the atomic mass for iron is 56, so that would be 2 times 56, which comes out as 112. And over here for the iron chloride, well, iron is 56, and we've got 3 chlorines, so 3 times by 35.5. And we've got a big 2 in front of it, so the whole thing needs to be multiplied up by 2 as well. And if you pop that into your calculator, that comes out as 325. So the last part of the question, all you need to do now, because it's all about ratios, is to set your last part out as set out here. So 11.2 divided by 112 multiplied by this here, 325. And once you pop that into the calculator, it comes out as 32.5 grams. So that's the cheats method. It's a ratio method. It's quick and easy to do if you set it out by just writing out the equation as shown in the question, popping the numbers in, and whatever you've got 2 bits of information for, like here, it's that top number divided by the bottom multiplied by whatever this part comes out as here. Now, for those of you amongst us who would like to go through this the proper method by calculating the number of moles, we're going to use our mass Mr. Mole triangle again, as shown below. Now, bearing in mind that this method it doesn't matter which method you use, whether it's the proper method or the cheats method, you'll get the same number of marks. However, once you progress into A level, you will be expected to use the proper method. So those of you who are really aiming high, it's better to learn at this stage how to do it correctly using the proper method. Okay, so it's the same question. We're looking to work out the maximum mass of the iron chloride that can be produced from 11.2 grams of iron. So I'm going to set out a little table over here. I've got my iron and my iron chloride. And down the side here, I'm going to write down the mass. I'm going to write down the MR, and I'm also going to write down the moles for each of those, okay, into a grid, just like I did in the titration method. Okay, so the information from the table, from the question, it says calculate the mass, the maximum mass of iron chloride that can be produced from 11.2 grams of iron. So I can instantly write in here for mass 11.2 grams. And I haven't got a mass of the iron chloride yet because that's what I'm trying to work out. Now, I can fill in this next part here. I didn't write that very clearly there. I can write in the MR of the iron and the iron chloride as well. So the AR of iron is 56. So we can write in here 56. And notice this time I'm not including the number of moles in this proper method because that comes into play a little bit later on. Okay, so I can now work out the MR of iron chloride. So for iron, it's 56 plus 3 chlorines, which is 35.5, multiplied by 3. And once you add all that together, it comes out as 162.5. Okay, so we can now use the triangle below to work out the number of moles. Okay, so the number of moles is mass divided by MR. So going back up to our table now, we've got the mass and the MR for iron. We've got those 2 bits of information, so we can work out the number of moles. So if we do 11.2 divided by 56, that comes out as 0.2 moles. Now if we look back in the original equation above, we can see that 2 moles of iron react to produce 2 moles of iron chloride. So we can say that this reaction is a 1-to-1 ratio. So 2 moles will react to make 2 moles, therefore 1 mole will react to make 1 mole. But we haven't got 1 mole and we haven't got 2 moles. In fact, what we have got is 0.2 moles. And because it's a 1-to-1 ratio, we can then say that 0.2 moles of iron chloride are produced. So now we've got 2 bits of information for our iron chloride, so we can use these to work out the mass. Going back to the triangle, to work out mass, it's MR multiplied by moles. And if you put into your calculator the MR, 162.5, multiplied by 0.2, you will come out with your answer of 32.5, which is exactly the same as the previous question. And obviously this does take a little bit longer, and I would make sure that you write the answer, 32.5, in the little box at the bottom to show the examiner how you've worked that out. So I hope you found these 2 tutorials useful, and hopefully they will give you a little bit more confidence when working out empirical formulae and reacting masses in your exam. Thank you.